to talk a little bit more about what we do in terms of DFMA and some of the hybrid structures that we deliver, but how we're trying to use digital and the benefits of digital to improve our performance, the performance of the buildings that we construct, how we deliver those buildings, and the capabilities of the people who work within the process that deliver those buildings with us. So we're PCE. We design and build concrete structures primarily using precast, DFMA. We've been around over 40 years and have a lot of experience of precast. But over the last 10 or 15 years, we've kind of developed this approach to combining DFMA with in situ concrete, and also combining, Elaine or scowl at me now, combining concrete with structural steel. Thank you. This is an example of a project we delivered, Broadmoor Hospital, which is primarily precast, but you can see the steel roofs on the buildings which we delivered, and the precast is combined with a lot of in situ concrete on site to ultimately optimise the performance of the concrete. Capella, a biosciences research and development facility, which is a building we delivered a couple of years ago over at Cambridge, the Adam Brooks Hospital site. Concrete frame structure, concrete cladding, steel frame plant room, 90% of it made off site, assembled on site, and the last 10% was done in situ. This is some high-rise resi we're doing in Manchester at the moment. It's primarily precast in all fairness, so sandwich panel construction, but sandwich panels with the windows pre-installed, precast balconies with the glass balustrades pre-installed. So it's kind of a very, very quick system build approach to delivering residential. The bathroom pods go into it, utility cupboards go into it, so prefabricated M&E goes into these structures, so very fast track building. Kingston University, a new teaching building there, which is due to finish this September, I think. Originally designed as in situ concrete, we've configured that as a precast building with in situ concrete slabs, or precast permanent formwork with in situ concrete slabs. That's the architectural structural colonnade that sits around that building, so it's quite an interesting structure. And then this is this morning at Battersea. So at Battersea we're delivering within one of the switch houses. The right hand side of the image you can see some new residential coming up above the existing switch house and power station, which is a combination of structural steel, precast concrete and in situ concrete. And we've got some in situ cores there. So essentially we're making buildings off site, bringing buildings to site, stitching them together on site, and using some in situ or on-site techniques to connect these things together. So the digital thing has become particularly important to us. I mean, I'm a firm believer that off-site and BIM sit hand in hand. The ability to configure building solutions as a kit of parts, an identity for every part that goes into that building, and then the data that sits with that part, these two things kind of sit hand in hand. So we've spent a lot of time over the last couple of years thinking about how do we collect data and how do we share data. The collection of data being the way we design buildings, but subsequently the way we make components and the way we assemble components on site, but also the sharing of the data with the people who are involved in the process to make that process compliant, efficient, safe, and resilient to the things that can go wrong in construction. So what we decided to do is we decided to set up this cloud-based hub, which essentially is a place where all of this information can sit and be collated and subsequently be shared in a real-time environment. So some of the things that we have in that hub are design information, some of the compliance stuff, the information we use for fabricating components, a lot of the health and safety, the training, the method statements, the material cost assessments, those kinds of things, the scheduling, the tasks, the reporting that we do. But probably one of the most important things we've got is this thing we call 80/20, which essentially is our our place for good practice and bad practice. The way we essentially collate the good things that we do, the things we want to keep doing, the way we do those good things, the place where we capture the things that didn't go so well, that we don't necessarily want to get rid of, we want to improve and put into the 80 bracket, if you like. So this 80-20 place within our hub is where we have all of our good information and all of the things that we want to share with the guys and the people we work with in our process. So just a little bit about design. Componentized design is quite difficult. It takes a lot of effort away from the construction phase. It takes a lot of definition. It takes a lot of hard work from a lot of people within that design process. So the efficiency of being able to share and collate that information is fundamentally key. But one of the key things for us is what we call smart connectivity. When you're doing componentized design, if you take a column, for example, what's in the column is important within the structure, but it's fairly easy to determine in terms of its performance, in terms of the reinforcement content, in terms of the way it's made. If you then connect that column to a beam, the way that column connects to that beam in a componentized design is fundamentally important to the success of that. So this smart connectivity is a really important part of that design process. And obviously componentization, when we're doing componentization, we need to be able to ensure that the components that we're configuring are manufacturable, they are logistically handleable, deliverable, etc. But also that they will fit the building systems that sit around it and the integration of those systems. And then in terms of the off-site fabrication, we could have these components being made in a dozen places around the country, in Europe, in Ireland. So the ability to share that information efficiently and that information to be appropriate to those people who are trying to make those components is fundamentally important. So just a little bit about the design process. Geometry, this is a structure that we're going to be delivering on the Olympic Park this year. We start in September, I think, on site. Some high-rise residential towers. So linked to that is the structural engineering that goes with that, the finite element analysis modelling and all the forces that sit within that particular structure and how those components are going to be designed. This is subsequently linked to the Revit model for those buildings and the components that sit within those buildings, so that we can see all of the stresses associated with those components, particularly where they connect together. And we can look at how the hybrid aspect of that design fits together. So where are we using DFMA, where are we using in situ concrete, where are we using structural steelwork to complement the concrete solution as part of the structural system. And then linked to that is the componentization of that building. So the way that is split into a kit of parts. We're now using families within our 3D design software to automate this process in terms of detailing these components and designing these components. Those families carry lots of data that ultimately we will collate over the course of manufacturing and delivering those components that ultimately will sit within that BIM environment at the end of the process. The interaction of those components, the repetition of those components. In precast we talk a lot about repetition, but unfortunately everything that we do is bespoke. Even if two things are the same, they're bespoke, because one thing can be made on one day, another thing can be made on another day, so there's something bespoke about the fact that the second one was made on the second day. Different people will be involved in that process. They can be made in different locations. We do lots of schemes where we have the same component made in different factories. It's the same component, but it's made by different people in a different environment. And we need to be able to collect this information in a central location, and document the compliance of those components and how they were made. We also need to ensure that the systems that sit within that building can be integrated. There's lots of buildings that we're involved in now where the M&E is prefabricated as well as the structure. The facades are prefabricated as well as the structure. So it's not just structure anymore. It's more about the broader DFMA delivery proposition. And on this particular scheme, we'll be pre-installing the facade off-site onto the concrete slabs before the concrete slabs are delivered. So there's a whole new raft of componentization that sits within the design and documentation and records we need to collate as part of that solution. All of the utility cupboards that sit within these apartments are prefabricated. The bathroom pods are prefabricated. There's talk of the kitchens being prefabricated. So this is all broadening in terms of the collation of this data and the subsequent sharing of this data as part of the delivery process. A little bit about smart connectivity. As I was saying before, ultimately componentized design or precast design or structural steelwork design, something that's made off-site and brought to site, if it doesn't fit together, it's not really much use. So the way that the components fit together and the forces are shared across those components are particularly critical. The efficiency of how that's done, the health and safety that goes with the guys who actually assemble these components and manufacture these components off-site is fundamentally critical to the design process. And the ability to show this information to the people who actually do these tasks is fundamentally part of our digital hub. We don't want designers being the only people who design buildings for us. We want people who make products designing buildings with us. We want people who assemble the components designing the buildings with us, because ultimately it's no good designing something that somebody can't build or somebody can't manufacture. So this kind of environment and looking at how these things fit together is fundamentally key to us. And then a little bit about buildability. What you see from this particular slide, this is a mock-up that we've recently constructed for a project where I'm not so concerned about the structural bits that you can see on that slide, but what you can see is all the temporary safety measures that sit within that system build approach. So all of the handrail and edge protection that goes with these components as they're assembled. Some of the temporary works is there as well, so you can see how the temporary works sits within the permanent works, and you can see how from a health and safety point of view people can assemble these components safely on site. A little bit about the 8020, our library, which I mentioned before. So key to us is the ability to share the information across the business and share it in real time. So our library of systems sits within this 8020 part of the hub. Each system has its own set of information, standard set of information, which sits within the hub. Each component within that system has its own standard set of information sitting within that hub, all accessible to anybody in the business at any time. But what we do is we use this as the basis of starting on any design, on any project that we use. So we absorb the good stuff, we put it into this hub, we then use that as the basis for designing the next one. So we don't design it differently next time if we found a good way of doing it and the guys who have assembled it said that's the way to assemble that component. We use that information, feed it into that hub, and we use that for the next design that we use. If it doesn't work so well, we also put it in there, so that sits in the 20 side of the hub. The 20 side of the hub is where we improve things, where we make things better, where we change things for the reasons why they didn't go so well the first time round. We've actually got an app that the guys have got on the phone now on site, so every time they see good practice, bad practice, lessons learned, they can send that into the hub logs that and creates a database of that information so that we can then sift that information and put that best practice and lessons learned back into the hub. And then in terms of the BIM thing is it's a journey for me in terms of each process we go through, we're essentially collating more information, more detailed information. I always like to think design as this, going to that when we're doing componentized design. We're trying to get from something that's this broad to something that's that narrow. And each step we go through, we gather more information, we collate more information. The key is doing it efficiently, doing it once, doing it in a way where that information goes back to the 3D model and sits with that component, sits with what we call the life cycle of that component. So communication's fairly key to this. An ability to digitally collaborate is fairly key to this. We've got sites all over the country, we've got factories all over the country, on the continent, in Southern Ireland working with us. We've got multiple prefabrication strategies on projects that are all working in conjunction with the superstructure delivery. So the ability to efficiently collaborate is fundamentally key to that. Also, the ability to use real-time data is fundamentally key to us. Data that's a week old or 2 weeks old is not really data, it's history. So the ability to collate that data, use that data, and influence the outcomes on a real-time basis is fundamentally key to DFMA. And then the ability to efficiently share that information across all of those different functions within that process that we're involved in is also key. What we've tended to find is this principle of workflows is fundamentally valuable to us in creating efficiency. So our system of, say, let's talk about, I don't know, developing a design detail, approving a drawing. Each time that happens, it sits within a workflow. What we don't want to do is we don't want people to look at information if that information is not ready for them to look at that piece of information. Information flows from a logical process, and it flows through a logical set of decisions to approve that piece of information. So each time we push information into the hub, into the process, it sits within a workflow, it goes to the person first in the stage of the workflow. They do their bit, it gets passed back into the hub, goes to the next bit, goes to the next person, goes to the next person, goes to the next person. Each time it sits with the person, they're notified that that person has that piece of information. So we can always track where this piece of information is within the flow of the history of that component. This is the same for manufacturing, it sits the same with on-site assembly. The hub allows us to collaborate digitally. I mean, this is not particularly new, but the fact that all the information is sitting in one place and not in multiple places is quite fundamentally key to us. We're all marking up the same piece of information in the same place, not the same piece of information in lots of different places, which becomes an absolute nightmare to manage. We've tried it, we can't do it. I'm going to have to speed up a little bit. Digital coordination, so this is an example of where we've kind of shared information with the site guys to compare and contrast information with what's actually on site, overlaying that information. Project groups who are working together digitally to develop solutions, sharing good practice. And this is quite a good tool, this digital conversation, there's multiple groups that we use, where we can essentially put a piece of information within the process, get all of the people working around it digitally, wherever they are in the country, and essentially finalise that piece of information while they're all sitting there at the same time. Real-time data, so everybody's using PDAs, smartphones nowadays, so every day we know exactly where our projects are. We have a plan, we have an actual, we have a backup plan to what we do if the actual's not working. We're now getting this to daily, so we've got daily reports within the system in terms of tasks that have been outstanding or tasks that have been executed, so that we can essentially manage the process very, very quickly, efficiently on a real-time basis. But then I think the most important part of this is the hub and how we actually use the hub. So we've got the 80/20 part of the hub, lessons learned, standards, best practice. So we've got the apps on the phone so the guys can share all that good stuff with us, but also access all of this good stuff wherever they are on site. We've got all the data in the same place, as I said. We've got one document, so we always know it's the current document that we're using. Single source of truth. Quality, compliance and checks done in a digital environment, so we know what's been checked, when it's been checked, has it been signed off. We haven't got pieces of paper telling us this anymore. Pre and post pour this is. There's one of the guys working in the factory with his PDA, checking the components before they're dispatched to site. In terms of assembly, using 4D now for planning and coordination on site. So we use the model to determine the sequence that we build things, not just the way we want to build it, but the way other people are working with us, particularly from other aspects of prefabrication or fit out, working with us, so that we can actually coordinate the works around them, or they can coordinate their works around us. Really valuable tool from a health and safety perspective. Really valuable tool in terms of monitoring progress. Next year we start on our first job where they're going to be flying drones over the job every day, monitoring progress. So we'll stop filling in pieces of paper or tapping stuff in on PDAs. The drone will tell us exactly where we are. The contractor wants to pay us on the basis of what that drone tells us as well. When the stuff arrives on site, when the components arrive on site, we record that the components arrived, Has it got any defects? We can record NCRs, those kinds of things. We can tell the factory it's arrived on site in good condition. We know in the office it's arrived in good condition. The guys on site have got access to all the training requirements they need digitally. We've got these QR codes now that sit with the cost assessments, the material data that we use, the methodology we use, so the guys can actually physically see the risk assessments that go with these materials that they use on site. We film these processes as well, so they've got access to this from a training perspective. Just an example of a typical process that we do on site. But guys can see what good practice looks like, how things should be connected together, as that speeds on, how it's finished, etc. Use the 3D environment in terms of how we build things now, so gone are the days of 2D drawings and guys with drawings on site looking what way does things go together. All of this information is specific to the components we're assembling, specific in terms of the levels, the setting out. What this also does is this allows us to update the model with the as-built information, so all of the information you see in these documents also has an as-built field next to it. So we've got, it should be this, it is that, so we know exactly where our buildings are. Bit on the smart connectivity again, so in terms of the information the guys use, and I'm going to wrap up